Welcome guys to today's class. In today's video, we want to discuss another important experiment in practical physics, and that is experiment on determination of height of a ceiling via alternative to practical of it. So if this is your first time of coming across our video, I'm saying a warmly welcome to you. Just feel free to click subscribe, enjoy the video, click like button, yes, share to your classmates, as many persons as possible to help him or her, because we want to see alternative to practical aspect of this topic, determination of height of a ceiling. This is the experimental setup of the experiment, where you see the ceiling represented this way. Then inextensible string, it could be a thread, so to speak. If you couldn't get a string, you use a thread. Yes, then pendulum bob. Then this is the total height from the ceiling to the ground. Then this is the height from the ground to the pendulum bob, and this is the height we are to be measuring. Make sure that the height of the ground to the pendulum bob is the particular measurement given to you to be used. You understand? And so we said this, we can take thread, we can use thread here to do it. Now, look at the procedures. This diagram above shows a simple pendulum suspended from a distance h equal from the floor. The center of the bob is at distance h from the floor. As we said, center to the floor, okay? The bob is set into oscillation and the time t is 20 oscillations. And the time t, that is 20 oscillation, and the time t for 20 oscillation is taken and recorded. The procedure is repeated 4 times by varying h and obtaining the corresponding values of time t. Fig 14b and Fig 14c. This is Fig 14a. Now, when we see Fig 14b, we will see their results. They want us to extrapolate the results using the scale that will be given to us. And this is possible how to run this experiment in GCE exams and other secondary exams or secondary schools exams, so to speak. So, Fig 14b and Fig 14c shows the values of hi and ti respectively. So we will see that fig, we'll see the figure, so to speak, where I is 1, 2, 3, 4, and 5. Determine and record the real values of hi and the corresponding values of ti. In each case, calculate the period t of the oscillation and evaluate t square. Record your readings on the table. So in this experiment, we will see the results or what they got in their experiment, the results of their experiment. And we now be able to deduce the result, bring out the result using the scale given to us. We will see how to do that. Then when we do that, we will now put inside our table of value and see the next thing to be done. Let's see the figure. Okay, so these are the results of the experiment. They are the one that provided these results for you. That is why we call it alternative to practical. Your work lies on getting the result, measuring out the measurements given to you. Read off your results out, compare it with the scale given to you, and put it on the table. 1 cm, each 1 cm gotten from this measurement represents 0.2 meter that you will get in actual measurement. So this is for the height and this for the stopwatch. Want to see how to read it off. Now, when we measured from this ground to H1, we got it to be 0.9 centimeter. Then when we measure from this ground level to H2, we got it to be 1.9 centimeter. When we also measure from this ground level to H3, we got it to be 4.2 centimeter. When we measure from ground level to this, we got it to be 5.5 centimeter. When we measured from here to what? H5. We got it to be 6.7 centimeter. So from here to here, H1, H2, H3, H4, H5. But some persons will make this mistake of writing this value inside here. This is for H1, H2, H3, H4, H5. I get what we're saying. And so what we're saying is that do not write this value here. What you do is you compare it with the scale given to you. That means the unit of this should be in meter, not in centimeter, because when we convert it will be in meter. How? 1 cm is to 0.2 meter. 0.9 cm will be giving you what? How many in meter? Use your calculator to press it. 0.9 times 0.2, that is 0.18. Here is 0.18. That is a meter. You do for the same one, 1.9 times what? 0.2. 1.9 times 0.2. That will be 0.38. So you are now getting the actual value, actual measurement. That is our alternative to practical. If you do not know how to extrapolate your readings and compare with the scale, or you just extrapolate and carry it directly, you have failed it. Yes, the essence of alternative to practical is you are not going to perform the experiment. They will do the experiment for you, give you the result, you extrapolate, you get off your reading, read it off and package on your table. Now, for the next one, 4.2. This is 4.2, not 42, 4.2. So 4.2 times what? 0.2. 4.2 times 0.2. That gives you 0.84. Then 5.5 times 0.2. That is 1.1. Then 6.7 times 0.2. That is 1.34. So we have gotten our values of height. What about our time? All this our time. T1, T2, T3, T4, T5. A lot of students will also make mistake in this timing. Remember, it is the reading goes this way: 0, 15, 30, 45. That means 0, 5, 10, 15, 20, 25, 30, 35, 40, 41, 50, 55, 60. That means this 0 is also your 60. That is the ending point. 0 towards 60. Okay, so we can still put 60 here to tell you that 0 towards 60. Now, let me tell you something. If you don't want to make mistake in this reading of this, get the reading accuracy of this instrument. Every instrument have its reading accuracy. That is the minimum value, the minimum measurement you can get from that reading, from that measuring instrument. What do I mean? If you want to get it, if here is 30, here is 35, bah? If here is 45, here is 50. Therefore, you say 55 minus 50. 55 minus 50. All over how many small lines do you see inside? 1, 2, 3, 4. When you start from the next line, you stop at the bigger line. 1, 2, 3, 4. We have 4 lines. So you say divided by 4. 5 over 4 will give me what? 5 divided by 4. 1.25. That means 1.25 seconds is the minimum value I should be getting. Now, because this falls at the third point, I will say here is 50. Now, these 3 points, will be giving me 1.25 times 3. What will it give me? Whatever 1, 2, 3 gives me like 1, 2, 3. That is 3. 3 times each. Each is 1.25. 3 times each plus 50. I will write it. We'll write 1.25 times 3 plus 50. That is 53.75. We'll write here 53.75. So that is your T, first T. For the second T, it points after the 50, the first line. That means 1.25 plus 50. That is 1.250 plus 1.25. That will be giving you 51.25. 51.25. Then the next one, it falls at the third line before 45, and here is 40. So 1.25 times 3, 3.75, and here is 40, right? Here is 40 plus 40. That is 43.75. 43.75. Then in the next one, it falls at 44. No, it falls at it's 30, 35, 4. It falls at 40. 40.00. Then for the next one, it falls at the first small number before after 35. You say 35 plus 1.25, because it is only 1 after 35. So that will be giving 36.25. 36.25. Okay. Then we have gotten our T. Remember that number of oscillation is given to be 20 oscillations. Okay. So what you do now is you say that capital T is equal to small t all over n, where n is equal to 20. Here is 53.75 divided by 20. That is 2.69. 2.69. Right? 51.25 divided by what? Divided by 20 gives you 2.56. 2.56. 43.75 divided by 20 will give you 2.19. 2.19. Then 40 divided by 20 will give you 2.00. And 36.25 divided by 20 will give you 1.81. We are just putting it in 2 decimal places. Then what about your T squared? 2.69. You know, this is the approximated answer. I will advise you, once you divide this, 53.75 divided by 2, it gave us, divided by 20, 2.69, right? Okay. You now say 2.69 squared. That gives you 7.24. 7.24. 2.56 squared. That gives you 6.55. Then we now say again 2.19 squared. 2.19 squared. 4.80. 4.80. And this is 4.00. 1.81 squared. 3.28. So that is how to make your table of values for this. Yes, remember we did approximations here. Next is to go to graph plotting and answering of questions. Let's see what they ask us to plot and how to answer the question that follows it. So these are the questions that we are asked to answer in this experiment. And question number 1 says, plot a graph of H on the vertical axis and t square on the horizontal axis. Determine the slope s of the graph and the error in the slope. Very important. Find the intercept and error in the intercept, hence deduce the height of the ceiling. Okay? Find the acceleration due to gravity and its standard error. Differentiate between oscillatory and rotational motion. State two precautions and how to minimize them. Then they ask a question. The bulb of simple pendulum oscillates with an amplitude of 2 times 10 raised to power 2 meter and period of 0.53 seconds. Calculate the speed of the bulb as it passes through the equilibrium position. So these are the things we have to take care of. While we are finding the intercept and error in the intercepts, hence deducing the height of the ceiling, the information says that is coming from this formula minus h over g. Like it's obeying this formula t equals to 2 pi square root of capital H minus h over g, where the capital H will be the height of the ceiling and the small h is what we plotted against t square. So we need to have this in mind. So we are going into the graph plotting, hence answer the following question. Let's go into the graph plotting. Okay, the first question we have to answer is plot a graph of h against t square. Determine slope and error in that slope. Now, this is a typical sketch of a graph sheet. Are you getting it? This is just a sketch of the graph sheet, so to speak. And we want to use this sketch to see how we can plot these readings we have here. We want to use the sketch. First and foremost, what do you do if you want to plot this graph? Write your date. Write the date of the experiment there. Then write a title. A graph of h in meter against what? Against t square in what? Second squared. Are you getting it? Then what you need to do is to choose appropriate scale. Looking at what we have here, h is here and t square is here. If you are choosing appropriate scale, choosing appropriate scale will help your points not to what? Jam pack one side. It will help you not to jam pack one side. Look at the highest. Highest is 0.1. Highest is 1.34. Lowest is 0.18. And in the instruction, plot a graph of h against t square. They did not specify starting from the origin. If they specify starting from the origin, then you obey that. But if they do not specify starting from the origin, all you need to do is choose where you are to start from. Remember, on our channel, we have posted video on what to do if they say starting from the word origin. And if you want to watch that, type Chidons Daniel. Just type Chidons Daniel. Chidons Daniel, how to choose appropriate scale. How to choose appropriate scale. Then you will be able to choose appropriate scale or see how to choose appropriate scale. Now, let's see how we can plot this. The highest is 7 and the lowest is 3.28. The highest is 0.18 and the lowest is 8. For your horizontal, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I say here to be 3, 3.54, 4.55, 5.56, 6.57, 7.5. Wow, it can accommodate. So if I come for horizontal here, I will say horizontal is what? 3, comma. So here 3.5, 4.0, 4.5, 5.0, 5.5, then 6.0, 6.5, 7.0, 7.5. Then label your Cartesian as a t square in second squared. Then this is for the x-axis or for the horizontal axis. For the y-axis, how can we put that? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we say that here is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0.0, you see that it will not go. Then if we say that here is 0 0.2, you say that here is 0 0.2, 0 0.4, 0 0.6, 0 0.8, 1, 1.2, 1.4, 1.6. Wow. So let's use 0 0.2. 0 0.2. So we bracket them. So we are going by 3 comma what? 0 0.2. 3 comma 0 0.2. I'm cleaning it so that we can write it carefully or clearly. 3 comma 0 0.2. 0 0.2 for the vertical, 3 for the horizontal. This 3 we wrote it first because this is with respect to 3 comma 0 0.2. That is this for x, this for y. Okay, and so 0.18. If here is 0.2, we have here 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, and here is h in meter axis. Then that means if here is 0.2 and here is 0.4, this minus this will give you 0.2. That is what it means. That means the beginning here should be about 0. 0. Yes. Middle of it 0.1, 0.18. Okay, very close. So 0.18 against 7.24. 7.24. This is 7. We now say that for us to know, next thing is to know the value of individual what? Small lines you are seeing inside your graph. We are taking all these small boxes as the big boxes you are seeing in that your standard graph sheet. And so if I say 7.5 minus 7, it will give me 0.5 all over 10 equal to 0.05. Wow. So this is what? 7. In between here is 7.25. So when you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 boxes here. That is what I'm trying to sketch. We have 10 boxes. 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 7.05, 7.1, 7.15, 7.2, 7.25, 7.3, 7.35, 7.4. So 7.25 is in between 1, 2, 3, 4, 5 at the fifth. That is 7.25. And we are looking for 7.24. We can minus 7.25 and plot it against 0.18. This is 0.18 and this is 0.2. This first point is 0.2, like this point, 0.2. So 0.18 should be close to it. So we will be locating the 1, 2, 3, 4, 5. We should be locating them here. That is close to that line for that 0.2. 0.38 against 6.55. This is 6.5. Then plus 0.05. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6.55 will be at the next line. And 0.38 will be somewhere close here. Close to 0.4. We have this point here. Then the next one, 0.84 against 4.8. This is 0.8. in between is 0.9. So 0.84 should be somewhere here against what? 4.8. This is 4.5. 4.55. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4.55, 4.6, 4.65, 4.7, 4.75, 4.8. Okay? I'll trace it up. 4.8, 4.4. Okay, we'll trace it up to here. Then we'll have it here. Then we move again. 1.1 against 4. This is 4 and this is 1. So it should be around here. Then we go again. 1.34. 1.34 against 3.28. 1.3. This is 1.3. Half of it is 1.3. So 1.34 against 3.28. So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 3.1, 3.1, 3.2, 3.25. We trace it up. 1.34. We locate them. And so we have located our points. Next is to locate our line of best fit. But before we get our line of best fit, we need to get our centroid. Add up all the values of h. When you're adding all the values of h plus 0.38 plus 0.84 plus 1.10 plus 1.34 divided by 5, 0.77. 0.77. So add up all the values of what? H and divide it by 5. You have this. Add up all the values of t square and divide it by 5. 7.24 plus 6.55 plus 4.8 plus 4 plus 3.28. And that divided by 5. 5.17. Okay, and so we locate them. This is 5.5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 7. Okay, 5.5. Oh, this is 5.1, 2, 3, 4, 5, 6, 7, 8, 9. 5.1. 5.15 against 0.77. So once you get your centroid, you circle it. Because in between 0.6 and 0.8 is 0.7. Somewhere here is 0.7, half of it. So 0.77 should be close to that 0.8. So you circle it as a centroid. Now we will get our line of best fit drawn. When drawing your line of best fit, ensure that it pass through the centroid. Let's draw it. We have located our line of best fit. This is the best fit zone and our line of worst fit, as you can see. And look at the vertical zone for this. And this is the top vertical for this one. Then we now say that, remember that they pass through this what? Centroid, so to speak. Try to use a sketch of, try to use your standard graph sheet to do your own. This is just a sketch. Now we say slope equals change in h over change in t square. For the best fit, here is about 1.26. 1.26. You now say 1.26 minus, come down to this 0.4. 1.26 minus 0.4 all over. Then for the horizontal aspect, this is about 3.5. 3.5 and what? 6 point what? 35. 3.5 minus 6.35 here. Okay, we now say 1.26 minus 0.4 divided by bracket 3.5 minus 6.35. That will be giving you minus 0.30. That will be giving you minus 0.302. Minus 0.302. Remember that this, wherever the vertical and horizontal intercept becomes your what? Your x2. Wherever vertical and horizontal intercept becomes your x2, don't just have mentality you have for that positive own that you call here s1, here no. Wherever vertical and horizontal intercept is your s2, is your s2. Okay, so we have noted that. What about the worst fit own? This is about 1.24. 1.24 minus, this is about 0.6 all over, this is about 3.15. That is where the vertical and horizontal intersect, is about 3.15. 3.15 minus this is about 5.7. 5.7. You also press it to your calculator. 1.24 minus 0.6 divided by bracket 3.15 minus 5.7. That is minus 0.251 equals to minus 0.251. What is the unit of this? Meter per second square. What is the unit of the meter per second square? Remember that it must have its units. If you did not attach the unit of what to solve, you will be subtracted some marks. Some marks can be subtracted from your answer or from your result. So this is meter per second square, this is meter per second square. That is by the way. So we say best fit slope is equals to minus 0.302 meter per second square. Worst fit slope is equals to minus 0.251 meter per second square, based on the results we have. Then how do we get our error in slope? There is need for you to get your error in slope. The reason is because it's possible that the slope you have is not in their what? Marking script. But when you're able to get your error in slope, the implication is that it will be able to what? Put you to be on a safer side. Okay. Error in slope is equals to find the modulus of best fit minus 0.302 minus what? Worst fit minus 0.251. Get their modulus. That means when you minus them, whatever you get, if it is positive, leave it as positive. If it is negative, leave it as negative. If it is positive, leave it as positive. But if it is negative, remove the negative sign. Minus 0.302 plus 0.251. Okay, we have it to be 0.051 minus 0.051. So I will remove that minus and put 0.051 meter per second square. Therefore, my slope finally should be, what is the best fit own? Minus 0.302. That one will remain as it is, but only the error of it that you will change to positive when it is negative. But when it is positive, remain it as positive. Plus or minus 0.051 meter per second square. That means in their marking script, they should be looking at, if they say minus 0.302 plus 0.051, if they check their marking script and this is not their answer, what they will check is, what about this plus 0.051? Minus 0.302 plus 0.051 will give you minus 0.251. Then if they check this and it's not in the option, the implication is that the last one is the last hope you have. Minus 0.302 minus 0.051 will give you what? Minus 0.302 minus 0.051. That will give you minus 0.353. All of them are meter per second square. So this is the possible answer, or this or this. One of them must be in the marking script. Yes. And so that is the essence of you getting your error in slope. If you get your error in slope, whatever answer you got as your experimental slope in your experiment, please don't panic. Try to get the error in slope using this pattern. The best fit on as it passed through this centroid, it connected only this point and which other point? Only one point it connected. It connected only one point here. But this point and this point fell out this side. This point and this point fell out the other side. We say it is okay because 2 points fell in opposite side. But if it is for worst fit, it doesn't concern me. As it's passing through this centroid, it carried only 1 point and this centroid. Then the other point that fell out, this is about line of worst fit. Look at it, carried this, even carried this point. But only 1 point is now falling out. Are you getting it? So as you have gotten your line of worst fit too, you can see it gave you 0.251. That will tell them that, wow, it's experimental errors you encounter that made you have the best fit on to be minus 0.302. Someone can say that this one you are seeing, that connected 1, 2, 3, and 4, that it is the best fit because it passed through the central and it captured about what? 4 points. Only 1 point it did not capture. Then the other one should be the what? Worst fit. So if we go by that, the implication is that here will be your what? Best fit, and here will be your what? Worst fit. And you come here, you change it. Here is what? Best fit, and here is what? Worst fit. You can see now that when you are dealing with experiments, graph aspect of it, you will see that we don't have one way. You can see before here was best fit and here was worst fit, and you check this worst fit, it could capture 4 points. 1, 2, 3, 4. 1, 2, 3, 4. Are you getting it now? It could capture 4 points. Only this point and this point fell out on opposite side. But the one of best fit we call best fit before, it captured only what? 1 point, and 2 fell this side, 2 fell the other side. So we go with the one that captured more points as the best fit own, and the one that captured less points as the worst fit what own. Are you getting it? So I can say that here is worst fit and here is best fit. Then my slope will change now. After I subtract, the same error of the slope is what we get. Yes, the same error of the slope, because when you say this minus this, it will still give you this. So, but the slope will be the best fit, which is minus 0.251 minus 0.251 plus or minus 0.051. Have you seen it now? That means this is your result. That is what I'm now concluding. This is my experimental slope, and this plus this will give me what? This plus this minus 0.251 plus 0.051. That will be giving me 0.2 minus 0.20. You can see. Then minus 0.251 minus 0.051. That will be giving me minus 302. All of them are still in meter per second square. You can see, just suddenly we have changed our result after analyzing what we got, that the best fit own, the former worst fit line of best fit, the former line of worst fit gave you what? That this enter, the centroid enter, and this point enter. That is okay. Only one point fell this side and fell the other side. But the former best fit own only carry 1 point and the centroid. 2 points fell this side, 2 points fell this side. That means the former worst fit own capture more points than the best fit own. And so we change it now that this is the best fit own and this is the worst fit own. That doesn't mean that when you just do the best fit, the one you call best fit, and you come and realize that the other worst fit is better to be called best fit, that you shouldn't change it. You are the one doing the experiment. It is the result to bring out that you will be used, that they will use to judge you. And so try to make sure you check what you are doing very well. Okay, and so we have this as our result, that our slope is what? Minus 0.251 plus or minus 0.051 meter per second square. Now, this is our error and this is our slope, and these are the other possible values because of plus and minus. Okay, then we move. We go to the next question. The next question says, find the intercept and error in intercept. Wow. Going for the intercept, we said that for our intercept of worst fit is about 1 point. Is about 1 point. Here is 1.5, right? 1.5. So it's about 1.42. No, it's about 1.45. About 1.45. So worst fit intercept of the worst fit is about 1.45. What is the unit? Meter. Then what is the intercept of the best fit? Is about 1.3. 1.3. Intercept of the best fit is about 1.3 meter. That means error in intercept will be equal to, find the modulus, 1.3 minus 1.45, or 1.45 minus 1.3, whichever one. But make sure the answer is in positive. You write 1.3 minus 1.45. That will be giving minus 0.15. That means I will say it is 0.15, no minus meter. That is error in intercept. So what should be my intercept now? I will say my intercept will be equal, what is the best fit own? Intercept equals 1.3 plus or minus 1.30 plus or minus 0.15 meter. Yes, that is the error in intercept. 1.3 plus or minus 0.15 meter. Please don't forget to write your scale. Your scale for vertical axis, for H axis, 2 cm, because we are calling all these bars the big bars. That big bars you have been seeing in your graph sheet represent what? That for H axis, this minus this 0.2 meter. Then for T square axis, we say 2 cm represent what? 2 cm represent this minus this 0.5 seconds squared. Very important. And so we have succeeded to get our what? intercept and error in intercept. How do we get our what? Acceleration due to gravity and what? The error in acceleration due to gravity. Watch how we do it. Remember that they said that this experiment obeyed the formula that said t equals to what? 2 pi square root of h minus small h all over what? G. And so we need to transform this equation that they said this experiment obeyed. Now to transform it, we have t squared equals to 2 pi. Okay, let's take it line by line. T equals to, take this square root, take this 2 pi, bring it inside the square root. If you want to bring 2 pi inside square root, you have to multiply 2 by itself, you have 4. Multiply by itself, you have pi square, bracket h minus. Are you getting it? Then you now put that square root all over what? G. Now removing this square root, you have to square this. Yes, t square equals to 4 pi square what? H minus h all over G. Then we want to make h subject of formula, since we plotted the graph of h against t square. So we say, first of all, divide both sides by what? 4 pi square. We have t square over 4 pi square. T square over 4 pi square, this times this, equals to gt square all over, like g times t square, it will give you gt square all over 4 pi square equals to h minus h. Then take this h this side, take the other one this side. H will be equals to what? H minus gt square all over 4 pi square. That means if you plot the graph of h against t square, this will be your slope. Are you getting it? That means minus g over 4 pi square is equal to, what is our slope? Minus 0.251. It is because here is negative. That is why we are getting a negative slope. So negative will cancel negative. Therefore, our g will be equals to, this times this, 4 shift pi square times 0.251. That will be giving us 9.91 meter per second squared. So this times this will give me this. So it's about transforming this to make h subject to small letter h subject of formula. So whenever you plot the graph of small letter h against t square, you will have minus g over 4 pi square as the slope and half h as the what? Intercept. That means the intercept we got represent our h. Yes. So what will be our intercept? Okay, we have gotten our g. Let's get the error in g. Let's get the error in g, so to speak. After that, we also get the intercept, which represent the height of the ceiling. We will get it. Okay, the error in g can be gotten using this formula. We say error in g all over g equals to error in slope, standard error in slope all over what? Slope. Then making error in g subject to formula g times standard error in slope all over slope. Are you getting it? What is our g? We have our g to be equals to 9.91. 9.91 times, what is standard error in slope? Our slope gave us this, and so we'll forget about that minus and write 0.251. Okay, error in slope was this minus this, right? Let's get it again. 0.302 minus 0.251. So 0.051 all over, what is your slope itself? 0.251. We'll neglect their negative, so to speak, the negative sign. Yes, because the negative sign is telling you that this is what? Passing through the what? I mean, the negative sign telling you that the slope is negative. So forget about that what? Negative sign. It's just because of this formula that you are seeing that negative, showing that it's obeying the rule of this formula. So when we say 9.91 times 0.051 divided by 0.251, that will be giving you about what? 2.01 meter per second squared. So we say our standard error in slope is equals to what? Standard error in G is equals to 2.01. Therefore, my G will be equals to 9.91 plus or minus 2.01 meter per second square. So the value of G can be 9.91 or 9.91 plus this and 9.191 minus this. One of them must be in the what? Option. And so this is our what? Answer. Okay? Then we go for what? How to find our what? Height of the room. Height of room means the intercept. So what we got in the intercept represent the height of the room. Yes, because that's h we have. We say this is equal to minus gt square over 4 pi square plus h. So this height means height of the room, and it represents the intercept. And so height of the room becomes, what is our height? We say the height of best fit, the intercept of best fit is equals to 1.3 plus or minus intercept of what? Well, this is 1.45, right? So plus or minus 0.15 meter. So that will be our what? Height. Yes, height of the room. 1.30 plus or minus. That thing we got as our intercept represent the height, so to speak. Then the next thing we want to what? Discuss is, they say find the difference between rotational motion and what? Oscillatory motion. Wow. When we talk about rotational motion, we said that rotational motion simply means motion of a body around a circular path or around a round path. Are you getting it? Motion of a body or movement of a body around a circular path or round path. That is about rotational motion. But when we talk about oscillatory motion, we said it is a to and fro motion of a body. To and fro motion of a body whose acceleration is directed toward the center of its position and is directly proportional to what? Displacement. That means to and fro, it can be in a circular way and it can be in a vertical way, as we see in the spring experiment, where they will mount a load on a spring and it will be moving up and down. 1, 2. So you can get oscillation this way. 1, 2, 3, 4. Are you getting it? Then you can get it by what? Circular way. 1, 2. So for oscillatory motion is to and fro motion of a body whose acceleration is directed towards the center of its position and is directly proportional to displacement. Whereas rotational motion is the movement or motion of a body round a circular path. It must be round. It cannot be vertical. It must be round. Do you get it? Let's have it in your mind. Then what about precautions? In this experiment, we have discussed precaution in the other one. And we said, since this experiment involves thread or string, it means that we will use ruler to do our measurement. So error due to parallels must be avoided. So error due to parallels was avoided while taking my measurement from the meter rule by placing my eye vertically downward on the meter rule. So mention the error you avoided and how you avoided it. Even this air resistance was also avoided by what? Closing your what? Windows and doors to avoid interference of the wind. Yes. We also, or by switching off the what? Electric fan. Any of these things can what? Make sure that we avoid air resistance. So you put it this way. Error due to parallels was avoided by taking my measurement vertically downward on the meter rule. That is one. Two, air resistance was also avoided by shutting the windows door, switch off the electric fan to avoid interference of the air or by the air. Then another thing, zero error, because we are making use of measuring meter rule, so to speak. We say zero error was also avoided by making sure that the reading is taken from zero or starting from zero. Yes, zero error was avoided by taking my measurement from zero. That is third point. Fourth point is that experimental error was also avoided by making sure that we can say that also experimental error was also avoided. Instrumental error, let's use instrumental, I think is better. Instrumental error was avoided by making sure that the stopwatch is in good condition, by also ensuring that replicate of the readings is done. Like you check the reading more than once. Are you getting it? So that is how you can checkmate that instrumental error, so to speak. Human error, experimental error, you avoid them. So let's put it this way. For that instrumental error, you avoid instrumental error by ensuring that the measuring instrument is in good condition. That is, the stopwatch is in good condition. The human error is also avoided by making sure that the readings is taken more than once. Just try to note all these errors, so to say, and how to avoid them. Then after taking note of that, also take note that we have a question that was asked at the end of the experiment, where they said the bulb of simple pendulum oscillates with an amplitude A equals to 200 meter. Amplitude 200 meter, that is 2 times 10 raised power 2 meter. And period 0.53 seconds. Are you getting it? They now say calculate the speed of the bulb as it passes through the equilibrium position. We are looking for the speed, and speed is equal to omega r. And what is omega? Omega is equal to 2 pi over t. Then because this is moving or is to pass through the equilibrium position, remember that from simple pendulum experiment, here is the equilibrium position, the origin. Are you getting it? And at this origin, x is equal to 0. That is the starting point. Once the x is equal to 0, the implication is that we'll be having everything to be a minus 0. That means we'll be having our distance to be a minus 0. That is a. Therefore, we say that v will be equal to wa, and is equal to 2 pi over t a. So once the x is at 0, the equilibrium position, the implication is that a minus x we have in the formula of simple harmonic motion. There is a topic called simple harmonic motion. We have this to be w v equals to w bracket square root of a square minus x square. Are you getting it? We have this formula. Now when we talk about equilibrium position, s is 0. 0 square is 0. A square minus, that will be giving you a square. The square root of a square will give you a. That's why we got v equal to wa. And what will it give you? 2 pi over 0.53 times what is your a? Your a is 200. It will give you the answer, meter per second. 2 shift pi times 200 divided by 0.53. That will be giving you 2371 meter per second square. So our v is equal to 2371 meter per second square. That is the unit of it. 2371. So this was gotten from simple harmonic motion topic. V equals to this bracket square root of a square minus s square, where this determines what, at which position. So if this pendulum bulb swing to this point, once it swing to this point, we say that here is amplitude. The amplitude, that means a square minus a square, it gives you 0. So at this what, at the extreme position, as the extreme position, the velocity will be 0, but at equilibrium position, the velocity will be WA. That is what it means. At extreme position, the velocity will be 0, and at equilibrium position, the velocity will be maximum, and that is what we have to be this. So that is how to perform this experiment, or to take care of this alternative to practical on this topic. Okay, if you find this video helpful, please feel free to click like, subscribe, share to many of your classmates, share your questions on my work comment section so that we'll help you out. See you in the next experiment.